Yuri is here. Hi, Yuri.
Yeah, I'm here. Do you hear me?
Yes, we can hear you really well. I'm really excited to to introduce Yuri today because he's one of my favorite developers at JetBrains. Um,
Thanks.
he's very knowledgeable about everything IntelliJ IDEA related. Very passionate about making the IDE better. I love collaborating with him because he's just really interested in how can we make this better for the developers. So we just talk about features, talk about improvements. It's been such a pleasure working with him. Today, Yuri is going to be talking to us about how IntelliJ supports new technologies, languages, and frameworks. And he'll show us how IntelliJ is not only a product, but also a framework for your own IDE features. I'm really looking forward to hearing about this session. Thanks a lot, Yuri. And I'm going to let you take it from here.
Yeah, thanks, Dalia. Let's move on to the topic. Hello, everyone. Again, my name is Yuri, and today I'm talking about plugin development, and I will tell you how we actually try to build new features for new technologies and languages and frameworks inside IntelliJ IDEA. So you can reuse our best practices, so you can use the same techniques to support your own technologies, your own maybe languages and frameworks. And there is a fun fact about me. I'm actually believe we already have enough frameworks and enough tools on the market. They are good enough for us, but I'm really sad that we have no really good support for all of them. Sometimes IDEs really have really good support for some technology, let's say Java or Spring, but for new technologies that just developed recently, we know such big amount of work done inside IDEs. And I'm working in IntelliJ IDEA team on features for new technologies, primarily for JVM framework support, such as Spring and Java EE. But also we built a lot of small improvements inside IDEs, such as custom languages, like most popular expression languages, template languages, and many different tools. Okay. So there is a small plan for this topic, for this talk. First of all, I'm planning to tell you more about IntelliJ IDEA plugin system, so we can dive into this topic and let's see how it is built inside. Then we will see how we can build support for custom framework, and custom framework today will be well-known Spring framework. Let's just imagine that there is no support inside IntelliJ IDEA for Spring. Let's imagine, because actually there is a good support for Spring framework inside IntelliJ IDEA. Then we will talk about custom languages, because sometimes people need really custom DSL languages or expression languages, or maybe file formats that are not that common on the market. And we will talk about how we can develop Lexer parser for a small language such as JSON path. Then we will talk about integration, because I in IDE stands for integration. So we cannot just skip this topic. So we will talk about integration with external tools, how we can call them, how we can integrate them inside IDE. And then I will share useful resources that will help you with your own plugins. Okay, that's the plan. And now I want to tell you the story about custom things in the world. Almost every company, has their own framework libraries, tools, maybe conventions, I don't know, maybe Docker images, and so on. And that's real life. We already built something for us inside our company, and these things are not open source. So there is no chance that IDE at some point will support your in-house framework or your in-house library. And at the same time, we all have a lot of routine tasks, and we cannot get rid of those routine tasks completely, because that's how our work consists of. And we actually deal with these 2 points. So we have our own in-house frameworks, we have a lot of routine, and that's how we live actually. So sometimes we try to build new frameworks and libraries just to deal with these routine tasks. And when we try to deal with the routine, we actually have like 3 choices. First choice is let's build more languages and frameworks. It's like obvious choice, yeah. We have a problem. Let's raise the abstraction layer and build more languages and frameworks. Nice. Now we have 2,000 different frameworks for JVM, and that's okay. Let's just try to choose something useful for us. There is a second option. Let's try to not introduce any libraries, any frameworks at all, but let's generate more code. That's obvious thing. We will build a new code generator, and while we are building this code generator, our competitors will just get all the market while we're building yet another code generator. Nice. And there is a third option for us. We can improve our tools. We can improve IDE. We can improve existing maybe command line tools such as, I don't know, maybe Docker or Terminal or something else. And today, let's talk about this third option. Let's try and improve our tooling for our custom needs. So for something that is not supported in IDE already, and try to see how we can employ IntelliJ IDEA not as just ready-to-use product, but as a platform for your own features, as a framework, like those frameworks you already built for your needs. And today I'm sharing our real experience. So everything that I'm show you here, we just do the same inside IntelliJ IDEA, or almost the same, because all the examples today will be slightly simplified, so we can just talk about them and do not go crazy on the complexity. So I'm trying to keep it simple, and we will talk about the ideas and mechanisms primarily, and not the concrete implementation choices. Okay, first of all, you can do a lot of things with IntelliJ IDEA plugin. If you build custom plugin for your own technology, you can do a lot of things. You can do languages, file formats, navigation, editor improvements, a lot of stuff. And if you see some feature in IntelliJ IDEA, like you use it for some public library or some open source tool, please note, you can build the same feature for your own technology. It is just, yeah, it is not secret knowledge. You can find more about anything inside IntelliJ IDEA in its sources, and if we talk about IntelliJ IDEA Community Edition, of course. And now let's talk about IDE internals. IDE is somewhat complex system. It consists of many moving parts. It has implementation of virtual file system, for instance. It supports a lot of languages. It parses them, highlights them. It provides editor capabilities. Also, it runs inspections over your code, provides indexes for your mechanisms of IDE. And it has UI library, extension points, and so on. And all our IDEs actually consist of plugins. So any language support, either PHP or maybe Java or Groovy or something else, this is plugin. This is not that just like something set in stone inside IDE internals. No, actually, any functionality for concrete technology, such as language or tool, this is plugin, and you can build the same, let's say, set of features for your own stuff. And if we check our IDEs, maybe 3 of them, IDE, Ultimate, PHP Storm, and RubyMine, here we have different sets of plugins. Okay, let's talk about plugin system. Plugin system, it's like a mechanism that allows different plugins to elaborate and communicate with each other. And here, every plugin implements something like a loophole called extension point. This is like a special interface that should be declared in IDE or inside plugin. And this is how plugins communicate with each other. And also, plugins may reuse existing functionality of IDE and its plugins. You should not reinvent the wheel. If we already support XML or YAML or maybe JSON, there's no need to build a custom parser for JSON or XML. You can add your features on top of existing plugins. And today I will show you how you can build something on top of Java language, for instance. And if we check one of existing plugins, let's say Groovy plugin, we'll see that Groovy plugin actually depends on Java plugin, on properties plugin, and also optionally depend on some of Ultimate modules, such as UML, for instance. So you can reuse many features from existing plugins and just employ them and leverage them in your features. Okay, let's get started. Actually, we try to build something useful. Let's see how we can start. First of all, you can easily create your first IntelliJ IDEA plugin right from IntelliJ IDEA. Just go to File, New Project, and there you'll find IntelliJ Platform Plugin option inside Gradle project type. That's how you can try to create new plugin. First of all, check or enable a plugin called Plugin Dev Kit. It is built-in plugin of IntelliJ IDEA. So just check if you maybe accidentally disabled this plugin. So please ensure that it's enabled. Then create a project with IntelliJ IDEA platform plugin option, and declare and implement extension points. Profit. Yeah, not that easy actually. Also, I'd recommend to use Kotlin for your plugins, but it is not required. You can use Java or you can use Scala for your own plugin, but we usually recommend Kotlin because it is more concise and shorter for plugin development. We actually use it for many APIs and mechanisms inside IntelliJ IDEA. Okay, so we created this new plugin. Now let's talk about the second option for new plugin. There is one more new option for your IntelliJ IDEA plugin called IntelliJ IDEA plugin template. It is a recommended way to start your plugin development. So previous one exists for ages already, but there's a new kid on playground. Let's check this IntelliJ platform plugin template. There you'll find a lot of useful options. For instance, you'll find existing scripts for building, deploying the plugin, and delivering it to the marketplace. Also, there are a lot of useful presets and properties for you. For instance, if I open Gradle properties, you'll find separate options for your builds here. So I'd recommend to use this IntelliJ platform plugin template for your plugins. Just go to GitHub, and there you'll find option to use it as template. Just go and use this template for your plugin. Okay, so using some of the ways we finally created a plugin, let's talk about its structure. There you'll find source code, source folders for your Java or Kotlin sources. Also, there is a manifest file called plugin XML. It declares all the functionality of your plugin. And there is a build script with a Gradle build system. If we open plugin XML file, we'll find something like this. It declares plugin metadata, like name, vendor, description, identifier. But most importantly, it declares dependencies on existing plugins. And in my case, today we will build plugin for Java IDE, for IntelliJ IDEA. So I will add dependency on common IntelliJ modules Java in my plugin XML. Also, we'll declare extensions here in plugin XML file. and actions. Maybe we'll build one action that provides something useful for our users. So that's the structure of plugin XML, and you can easily check it in IDE. Okay, let me just switch to IDE and show you the same picture in code. So if I open my IntelliJ IDEA, you'll find the same structure, like build Gradle with my dependencies and options, source sets, resources. There we go, and open plugin XML, all this stuff for my company functionality. And today we just imagine that there is no Spring framework on the market, and we built it like from the ground in my company, and that's why we built a plugin for it today. Okay, just let me switch back. So let's talk about extension points. So previously, I've shown you that there is a special section in plugin XML, and there you can declare your extension points, such as actions, inspections, intention actions, reference contributors, and so on. We register them in this file, and you can find more extension points inside IntelliJ IDEA files. They are available in your project. So if we go to source code and try to find file by name, long extension, like long extension points XML, and open this file from library, you'll find a lot of extension points, and you can find their interfaces. You can read what's this, which parameters they have, and you can explore more like documentation and hints here in concrete files of the platform. So you can easily check internals of IntelliJ IDEA right from your IntelliJ IDEA plugin code. And if we check existing plugin, let's say Groovy support. Groovy plugin is open source plugin, and you can easily find its source code on GitHub. There will be 1,300 lines of plugin XML to declare all the options that all the extension points provided by Groovy plugin. So you can implement a lot of things. And you can easily find all source code of IntelliJ IDEA community on GitHub inside JetBrains organization. And also recently, my colleagues from IntelliJ IDEA SDK team released one useful tool called IntelliJ Platform Explorer. Highly recommended thing. There you can find existing implementations of extension points. So let's say there is some plugin that already implements, I don't know, maybe let's say it implements line marker, for instance, line marker. And we want to check code of this plugin, let's say Kotlin, or I don't know, maybe Scala or Flash and something else. And here you can find source code and of this plugin. You can find all the extensions implemented in this plugin and check source code of this plugin with this extension point. So here you can find more examples of already implemented functionality inside open source plugins. Highly recommended. But what you can actually do with all these extension points? So yeah, we have all those extension points, and what? let's see how we can employ them. So let's imagine that we have developed a framework, and this is our own custom framework, which is very similar to Spring, for instance. Like just imagine it. And what can go wrong actually? So yeah, we've implemented something, and what? IDE will stop working with it? No, IDE will work with it. But what's happening actually? Let me show you. There can be some problems. So I've opened this sample project, very well-known sample project, like Spring Pet Clinic. It's like example of project based on Spring Framework. Let's open something like vet controller, some code. Yeah? And here I see a lot of gray markup. Like I see this method is never used. Why? Why IDE doesn't understand that get mapping is something like entry point? I don't know, because IDE is not a wizard. It cannot like read your thoughts and understand all the stuff automatically. Someone should tell IDE that this get mapping thing is declares entry point. Let's try to fix this for our own custom Spring Framework. So let's say we need to say IDE, if something is marked as get mapping, this is useful stuff. You should not highlight it with gray things. So this is problem called implicit usages. And the problem actually is frameworks nowadays are very powerful, and they really love nice naming conventions, implicit conventions, and they try to like automatically find and scan something from your code. And that's what we've seen right now for welcome controller. Let's teach IDE to understand those implicit usages. That's simple stuff, just to understand how we can declare extension points and how we should work with IntelliJ IDEA plugin code. So we start with extension point called implicit usage provider. We declare it inside plugin XML with the corresponding tag name, just like implicit usage provider. We declare here Java class or Kotlin class called Spring Implicit Usage Provider. It should implement 3 methods: is implicit write, is implicit read, and is implicit usage. So let's implement this stuff. But see here we have some magic wording. Like I see this PSI, like PSI. What's the PSI? How I can understand this abracadabra? Let's try to figure out what's PSI actually. PSI is a special program structure interface. It's a representation of your programs, of your like code, file formats, and lexical structures. It represents syntax structure of files and also includes semantics and provides references between elements. And everything in IDE, like almost everything inside IDE, is represented by a special object with interface PSI element. So PSI stands for program structure interface. This is just elements that represent your code, your syntax trees. And languages, different languages such as Java or Kotlin or JSON, they provide their own implementations of this PSI elements. So each file, each like standard file, Java file, or maybe JSON file, consists of many PSI elements, and those PSI elements, they form some structure called PSI tree. And let's try to see, for instance, for Java, how this PSI model looks like. Let me go back to the IDE. So here we see this like Java file. Let's open tools and find here view PSI structure of current file action. This action is available inside your debug IDE. It's IDE instance that is up and running if you run your plugin from Gradle. And let's click here with this option. So now I see PSI structure of this file, and I can even try to find which symbols and which like strings, what is their representation in memory. For instance, here that repository, this is PSI identifier, and there is a Java code reference element. Also, this is type element, and it is inside PSI parameter. So this thing called PSI tree, and you can easily explore it and see the structure of the file. In my case, this is Java file. This is a useful thing because let's see what we have for this unused method. Here for method, we have PSI identifier inside of structure called PSI method. Nice, we know this stuff is PSI method, so we should check that thing that will be passed here. Let's go back. So here, if we receive PSI method, we should return true if it is annotated with some magic string annotation. Let's see how we can build this in code. I'm going to plugin XML. Here I have extensions and extension point, and first extension point actually is implicit usage provider. Let's go to the code. So here I have implemented this like usage provider. It is very simple. If we receive class, it should be annotated with one of bin annotations. And if we go here, you'll find regular constant declarations. So I just hard code all these annotation names, class names, and maybe something else from the framework. This is how my plugin code actually interacts with the framework. So my plugin should somehow know which annotations and their semantics used in framework. So I just easily add constants. I will just decide that bin annotations are component and controller for simplicity, for the sake of simplicity here. And if class is annotated with one of bin annotations, I just return true. This is something useful, something that is used implicitly. And in case of PSI method, if we receive PSI method, it should be public, it should not be static, and it should be annotated with one of controller method annotations. And today I only have like 4 controller annotations, controller method annotations: get, post, mapping, init binder, and module attribute. And that's it. And let's see what will be. Just restart our plugin. So I've just enabled implicit usage provider, restart the plugin. And let's see if we now, if IDE now understands these implicit usages and highlights something with gray highlighting. So it is running. Now, let's wait for resolve and scan. And finally, IDE will know that it is used implicitly, and we should not. Now you see this color, regular color of declared method. If I remove get mapping, it becomes unused. So now IDE understands that get mapping declares something called entry point. So wow, nice, IDE understands me. I'm happy. Okay, we've implemented first useful extension point. Nice. Let's proceed to the next useful stuff. There is a special thing in our IDEs called inspections. It is a like special inspector, actually, some mechanism that statically check your code, traverse PSI tree, and check if there are any errors inside. Maybe not only syntax errors, maybe like semantic errors or correctness errors, maybe data flow analysis required to figure out find some bugs. We have seen today, Tagir shown us how data flow analysis can find pretty strange bugs in your code. That's inspections. And there is a special interface called local inspection tool. You can implement it in your plugin and provide a custom inspection. Let's try to build a simple inspection that will enforce a coding convention. In the Spring world, there is a recommendation from Spring team that one should not use auto-wired annotation on a field because of testing reasons, because of initialization reasons, many reasons behind this decision, but auto-wired annotation on a field is not recommended. So we implement this local inspection extension point for Java language, and we will put it inside a group with name Spring. We will enable it by default because I want to enforce this coding convention. And we will create one more Java or Kotlin class that will implement this extension point. And here we will implement some of methods of abstract-based Java local inspection tool. In our case, it will be check field, not check method actually, but check field. Let's see how we can implement something like this. So I'm going to uncomment this local inspection. So that's how we define new local inspection. It will be Spring auto-wired inspection. And here I will declare only one overridden method, check field. It will receive object called PSI field. This is representation of field in Java. So if you declare some field inside class, it will be PSI field. And if this field is annotated with auto-wired annotation, then I will highlight identifier, name identifier of this field with field injection is not recommended warning. So let's see how it works and how we can see how it works actually. Yeah. So we just restart our plugin, and right now when I just click here run, IntelliJ IDEA builds a plugin and puts this plugin inside a special debug instance of IntelliJ IDEA. So my daily life is as follows. I build IntelliJ IDEA using IntelliJ IDEA. So yeah, that's kind of cool. Yeah, so let's open and see our inspection. So now let's try to find something annotated as auto-wired. I will try to find some example in my project. Auto-wired. Okay. So here, auto-wired used correctly. It is used for a constructor. I will put it on my field. And now here, see, we have this nice warning. Field injection is not recommended. All your colleagues will receive this warning, and that's how you can enforce your powerful coding conventions in your company. So you can just say, guys, you should not at any time use field injection. Yeah. Okay, so that's how we can build something useful like inspections. And inside inspections, you can build something really powerful and cool, and even provide your quick fixes. You probably know we have quick fixes for inspections. Let's go back to slides. Nice. And let's talk about the third topic for today for code. Our PSI tree consists of not only from elements, but it has references between elements. And that's how actual navigation works inside IntelliJ IDEA. You just go to the code, hold Control keyboard key, click, and you go to something like definition of owner or definition of string, integer, and something else. And references actually can provide auto-completion variants, and plugins, including your plugin, can contribute new references to existing languages. So you can provide, for instance, references to maybe external files or external entities inside Java. Let's see how we can employ it for our own custom framework called Spring Framework. So let's build support for things called property references. So in Spring Framework, we have ability to use interpolation using this $sign inside a value annotation. And here we mention property from one of property files, for instance, from application.properties file. And here I want to get auto-completion for this property names and navigation to declaration of this properties. And that's how I work. Yeah, I just open a source code, click here, and go to property file. But by default, this is just do not work. So let's try to see if it work or not. So we go and find the value. Here, yeah, we have some value. I just click, and IDE doesn't understand my custom framework today. It doesn't know that this nice interpolation sign means something. I need to teach this robot to understand my code. So let's build a new extension point called PSI reference contributor. And let's add our own custom reference here so we can go and find this database URL property. So I go back to IntelliJ IDEA with the code. Stop this. I will uncomment one more extension point called PSI reference contributor. This is my class Spring property reference contributor. And here I register special reference provider. Reference provider should define actually two things. First thing is a pattern, something that designates like place in code where we should insert references. It will be some PSI language injection host in my case, for instance, some string in Java, which is annotation parameter of value annotation. So inside the value annotation of Spring Framework. And second thing we should build is a PSI reference provider, something that will create these references. And here I will try to find some places inside string, some like ranges, where we have interpolation with useful helper utility class from IntelliJ IDEA Community Edition with placeholder text ranges class. It will give me all the places where in my string this interpolation pattern exists. And there we will create placeholder property reference, special reference class that is implemented in my plugin. It is not built from scratch. Here I am reusing existing property reference base class from IntelliJ IDEA community. So you can and even maybe should reuse some code from IntelliJ IDEA. So I'm reusing this property reference base class and only customize some of aspects, some of like behavior aspects of this class. For instance, I provide reference variants options for auto-completion, or I customize property files search. And in my case, search will be just like very straightforward. I will try to find all the config directories and all the files with the name starts with application. That's just like this. Like naming convention in my company is pretty easy. Application.property means configuration file. That's it. That's how we create this property reference class. Let's see how it works and what features it provides. So we restart the plugin and let's see if it provides something useful for us. So we restart plugin and let's see how we can use this auto-completion and references, because I need this for my daily work. And I want to use navigation, maybe rename refactoring, find usages, and something else. So now if I go to some place where value annotation is used and just put cursor caret here, you see there is a highlighting. If I hold Control, I see that this is this key references value user inside application.properties file. If I click here, I navigate to application.properties file. That's nice. If I just try to autocomplete inside this braces, I'll see all the options from my application.properties file. Yeah, finally I have something useful from my IDE. So I can see this navigation, and I can even rename all the occurrences of this key. So I just go and use standard Shift F6 shortcut, just rename. and it will be not database, maybe db.url, rename. And if we go to the file, that's it. It is renamed everywhere. Just like I've only implemented references. I've not implemented any refactor capabilities. I've not implemented any find usages, but find usages already works. If I trigger find usages for this db.url, I find usages inside Java classes. That's nice. So I can easily rename all the occurrences and refactor my code safely. Why why this magic works? Let's talk about this. So find usages and rename refactoring. By default, find usages mechanism inside IntelliJ IDEA finds elements with the same text. So actually, text of the property key and the string inside Java, it is the same text. So that's why find usages finds this. It tries to find references in this place where we have the same text. And if it finds suitable references to the same element, it matches them, and it shows this as occurrence. And it works automatically. So by default, for simple cases like keys inside properties in Java, it works magically. I should not implement any custom find usages on rename refactoring actions. And you can even customize it for complex cases. For instance, in Kotlin or in Groovy, we have property usages that try to find getters and setters not only with the same text as property name, but with get and set prefix. So that's what we get if we just add references. So we just get find usages, rename, and navigation, and all the stuff. Nice. Okay, that's it with custom frameworks. What's next? Actually, we have not that enough time maybe for full-blown custom languages introduction, but I will show you some stuff about custom languages. Let's say we have implemented some custom language, let's say JSON path, for instance, and IntelliJ IDEA can help us with support of this language. So we can build custom file type, grammar for this language, lexer and parser. We can implement highlighting, completion, inspections, refactorings, all this stuff. But today, let's implement first only the first four things. And here, special plugin called Grammar Kit will help us. And first of all, you should go and install this plugin if you need to implement custom language support. This is additional plugin, and it provides support for Backus Naur forms or Backus normal forms grammars. And also it provides editor support for JFlex Lexers editor. It can generate Lexer by BNF if you are lazy enough, as me maybe. And also it generates readable parser and PSI code generator. You should read this tutorial available inside in our IntelliJ IDEA SDK docs on custom language support. It shows you all the aspects of custom language support. But today I will just only show you some of them. Okay, let's say we need to implement some language, and maybe I use some language similar to JSON path. Let's find some usages in Pet Clinic. So here you see we have some strange string with a $, vet list, ID, something like expression language, and I want to have highlighting for it. I want to have syntax highlighting and maybe years shown here. But now IDE doesn't understand that this is like some custom language called JSON path. Let's implement support for this language like in 5 minutes, for instance, like very, very fast. First of all, we go to our plugin and implement one first extension point called parser definition. This is where we declare that we have one more language. It will be JSON path language. I just declare these classes. They are easily created like by hand. You can just declare here options. Is it case sensitive? What is the file type? There are no logic here, just like options. And this file type will be named JSON path, description JSON path, and default extension is the same. And then when I declare this parser definition, I go and write grammar for my language. Let's see how we can do this. First of all, I go and write something like BNF form for my language. This is how GrammarKit helps me to write these BNF files. I see all the highlighted stuff, I see my tokens, and I see all the generator options, because I'm not going to write parser and lexer by hand. GrammarKit will generate them for me. I will only declare grammar for this language. And here I declared standard options, standard like tokens and elements of this language. Here I have something called head and something called segments. And I can even try my language right here with Ctrl-Alt-P shortcut. So it opens editor of this language, of this not yet built and compiled language, and I can try my language here. So I write something valid. This is awk, this is parsed. But if I, let's say, make a mistake, here we'll have like syntax error. So that's how I can easily try to test my BNF without even compiling my project. So I can easily open this preview button. And when I'm done with my BNF, I can generate lexer and parser for my language. You can click here with right mouse button and find generate JFlex lexer. I will not just try it right here. I've already generated one. And generate parser code. Let's generate parser code. So just generate parser code. IntelliJ IDEA will generate it. And here you'll find a lot of generated code. Like you'll find all the PSI structures, all the PSI interfaces. You'll find parser. It is quite big, but it is a good idea to generate it instead of writing manually. Also, when I go to my lexer, here I'll find I'm using only simplified set of tokens in this language, like this standard set of keywords, and only identifiers and numbers are supported. So now I have lexer. I will generate JFlex generator from this lexer definition, and IntelliJ IDEA will generate lexer code for me too. So this file with 600 lines generated. Nice. I should not write it manually. So that's how we usually build new languages like grammars and flex definitions. And when it is ready, we go and implement some of extension points for custom language. For instance, I've implemented simple brace matcher. Like, let's go and see this brace matcher only has two brackets, like one pair of brackets supported, L bracket and R bracket. So that's how we match them in code. And if we run this plugin, let's run it. Like I will run this. And here we'll find syntax highlighting for the language. It is implemented with JSON path syntax highlighter. Here we have no behavior tool, only simple highlighting options, like which token with which highlighting type should be considered. So here I only specify that comma should be highlighted with default highlighting colors, comma. And for instance, if something called JSON path context, I try to highlight it with static field highlighting. And for identifiers, I'm using instance field highlighting. So I'm reusing existing colors from IntelliJ IDEA color settings. So let's see how it works. So now we have this language. Let's try to inject it. Trisha already shown you how we can easily inject any language in string literal. Let's use it. Like I use Alt-Enter and inject language. And here we can find JSON path language. So now we can use it everywhere. Like add it here. And wow, we now have highlighting for this language. If I like make a typo, I see syntax error, I can open JSON fragment here and see I can edit it right now. Yeah, it is parsed correctly. There is a syntax errors. I can use some of keywords from my JSON path implementation. That's how we really start building languages. And in the recent version of IntelliJ IDEA, in EAP version, you'll find ready-to-use implementation of JSON path language. So please try it if you use JSON path in your like daily routine. We already implemented JSON path for you, and you can check a full code of this implementation in IntelliJ IDEA Community Edition. It is fully available on GitHub. So that's how we usually build languages and their support. Whew, nice. Let's talk about some of the options for integration briefly, like in a couple of words. This is not all of the options for you to implement custom integrations. You can integrate with external tools, such as command line tools, such as external libraries, and there is easy way to integrate with something. If there is a JVM library that implements integration, for instance, for Gradle, for Docker, for Swagger, we use Java libraries for integration. There is harder option for you. You can connect to external API via network or Unix socket. That's how we integrate with Spring Initializer service, and that's how we integrate with Java Debugger, for instance. And you can easily access your network resources from IntelliJ IDEA plugin. There is a pain and suffering option for you if you try to run something like command line tools, but we also provide mechanisms for you to run command line tools such as Git, Docker, NPM, and you can run your own command line tools. And finally, there is out of the ratings, there is a web content integration topic. I will briefly show you what I mean here for web content. If we just open here, just open the README file, and here, see, this is web content. And we can even open DevTools for this web browser. Actually, this right pane is a Chromium browser, full-blown web browser integrated inside IntelliJ IDEA. So please know, you can easily integrate many web stuff like Swagger UI, I don't know, diagrams, external services, and so on in IntelliJ IDEA with JSF. It is just nice option to integrate something. And I can even show you more powerful option. We have integrated Swagger UI with the same mechanisms. So here we have a web page from Swagger UI, which is running inside IntelliJ IDEA, actually inside of Chromium browser, which runs inside of IntelliJ IDEA. So you can easily integrate even JavaScript and HTML UI inside of IntelliJ IDEA. So there are more integration options than you can imagine. Oh, so briefly, there are these 5 options for your integrations. Please check them. And if you have any questions, I believe you can ask more questions on our resources. We have many useful resources for you. For instance, JetBrains platform Slack, where you can ask technical questions. We have dedicated documentation pages for plugin developers in IntelliJ IDEA SDK docs. And also, you will find all the examples from the talk on GitHub. So I believe that's it for the technical content. Thank you. And if we have any questions, it would be nice to answer them all.
Yeah, this was awesome.
Thanks.
I remember starting to develop plugins and I saw that plugin, that XML file, and I was like, I have no idea what's going on here. So it would have been really nice to have the presentation back then, understanding like the extension points and all those things. So thank you a lot for that. And I think it's really nice to have the IDE do something customized like that. I don't know. I think it's magical just having the IDE do that. So the questions that came in the chat, the moderators did a wonderful job answering them. And one of the questions that I wanted to reiterate is if you can write plugins in Groovy. They said yes, but you can expand on that if you'd like.
Yeah, actually, you can write plugins in Groovy, and I can even emphasize here. Actually, Groovy plugin is partially written with Groovy. Yeah, so you can even go crazy and write plugins for JVM languages on those JVM languages. And even more, Scala plugin is mostly written in Scala for IntelliJ. So funny facts about development inside IntelliJ IDEA.
Cool. Another thing that I had a question about. So I've heard about the template before, but I wasn't really sure what comes with that. So if I'm a beginner, I want to just write my first plugin and I want to use a template, what would you recommend me do?
I certainly recommend go and use template on GitHub, because it is like predefined and consists of all the useful stuff. Just go and click use template here. There you'll find all the default options and useful documentation on this, and even examples of code that will help you to define your own extension points. So this is all the best practices you should use in your plugin. They are all concentrated in this repository. So even you are not planning to use this plugin template, maybe check it and check if you're doing all the stuff right.
Awesome. Okay. Last thing I wanted to wrap up with is I wanted to ask you, do you have a favorite plugin or a favorite feature that you've worked on while working on IntelliJ IDEA?
Yeah, recently I've been working on this JSON path support. This is pretty exciting when you build something from scratch, like new language, new tooling, new like parser or definitions. So I'm really excited about languages, extension points for languages and so on. Yeah, that's just cool stuff.
Awesome. Well, thank you so much, Yuri. I loved this presentation. I appreciate you being here with us.
Yeah, thank you, Dalia.
Thanks.